Hi, good afternoon. My name is Jongkyu Shin from Seoul National University, and I'm a master's student at Music and Audio Research Group, Graduate School of Convergent Science and Technology. Today I'm here to present one of my research area called Mudio, a museum audio guide system using inaudible high frequencies in mobile devices. Sounds familiar, huh? Okay, so the platform in exhibition systems is changing, starting from the human guides. The passive systems which require users' manual input, such as key entry, came out. And with the advancement of the technology, the active systems which retrieve information automatically are used in many exhibits today. But these systems have some limitations. In case of using RFID or IR, they need extra device or discrete device to utilize it. And also, most of the systems have the close-by contact mechanism within few centimeters, so explicit interactions such as the tagging or holding motions are required. For the same reason, the systems cannot handle multiple users at the same time. Okay, so the Mudio system utilizes sound waves as the communication signal, and it has the advantage. The advantage can be high compatibility, implicit interaction, and handling multiple users simultaneously. And the inaudible high frequency, also known as near ultrasound or very high frequency or taper. I guess you all know what that is. Okay, so I'll just skip. And the biggest, those signals are recently used in commercial targeted marketing systems as identification systems. And the biggest difference of Mudio comparing to those systems is the signal structure. But I'll make it very short here because otherwise I would need extra 20 minutes to explain. So in short, the sound signals from related work have time-dependent structure, which means they have the starting points and the ending points. So if any missing part or interfered sample are in between the signal, it needs retransmission and it takes time. However, Mudio system utilizes the time-independent structure signal, making it possible to analyze with only one pulse of the signal. Okay, deja vu. I think you all know the concept. And here's the picture of our system's transmitter. It's the size of a cigarette pack and composed of 1-inch tweeter speaker and a PIR sensor for human movement detection. Okay, we also implemented the zone detection feature, which is the proximity detection process. And this can be used to create information hierarchy, such as providing simple information when the user is in the far zone, and then provide detailed information as the user approaches to the closed zone. Okay, so here are some test results of our experiment. And first experiment was to testing 4 transmitters in a straight line. A, B, C, and D stands for each artwork, and the distance between them is the variable. Standing on the blue circle, we tested 20 times, and the variable was set to 50, 100, and 200 centimeters. We consider it as a success if the system detects the front-facing one, otherwise fail. And as we expected, we got better results with increasing distance. The next second experiment was the several artworks in different positions. We wanted to see in the test how well the system performs when the hearing spots, the blue circles, are overlapped. Contrary to our expectation, the results are good. A possible explanation to this is because inaudible high-frequency tones are extremely directional. So holding the device in front of the body like this, the human body acted as a sound shield, preventing other interfering signals to reach the device. We also conducted the user study, and to compare the systems, we developed 2 versions of apps. The left one on the left one is the manual app, which has the number entering form, and the right one is the automatic system, Mudio. 12 participants were in the study. Okay, it's the dimensions of the exhibition area. The system was installed in Seoul National University Museum of Art during the exhibition named Love Impossible. 5 transmitters were installed to cover 7 artworks in different forms. Okay, it's the picture of the installation, and the artworks are blurred due to the policy of the museum. Sorry. Okay, here are some brief survey results from the user study. is the biggest two questions. And on the question of how easy it was to use the systems, the test indicated that the automatic system was easier to use than the manual system. On how interfering the system was while focusing on viewing the exhibition, the test indicated that the automatic system was less interfering than the manual system. However, there was an outlier stating that the automatic system was very annoying since it changes information automatically as on the screen as the user approaches to other artworks. The person wanted to manipulate what to see, so there was a outlier. Yeah. And limitations in Futurework. First, the sensitivity to the energy of incoming signals. The microphone's ability to pick up signals decreased dramatically as the frequency goes higher. And also the scalability issues. The current system can only provide up to 255 IDs since it uses 8-bit binary transmission. And although inaudible high frequency is inaudible to most adults, but some children or animals can hear them, and it may even cause hearing damage. And one thing I didn't mention in the slide, it would be essential to establish an app interface considering visitors with different levels of knowledge. Okay, thank you. This is the end of my presentation.